Let us have factoring polynomials. First, we have common monomial factoring. Example, 56a cubed minus 8a. The greatest common factor of 56 and negative 8 is 8. And the greatest common factor of a cubed and a is a. So it is the variable with the least number of exponent. So the GCMF, or the greatest common monomial factor of 56a cubed minus 8a is 8a. To find the other factor, just divide 56a cubed by 8a, that is equal to 7a squared. Remember, in dividing polynomials with the same variable, just copy the variable and subtract the exponents. So this one, a has an exponent of 1. So 3 minus 1 is 2. Then for the second term, negative 8a divided by 8a, that is equal to negative 1. Take note that when we are going to divide opposite signs, the quotient is negative. So the factors are 8a and the quantity of 7a squared minus 1. Another example, 80x to the 5th power minus 70x squared minus 60x raised to the 7th power. The greatest common factor of 80, negative 70, and negative 60 is 10. And for the variable x, the greatest common factor is x squared. This is the variable with the least number of exponent. So the GCMF is 10x squared. To find the other factors, or the other factor, we have 80x raised to the 5th power divided by 10x squared, that is equal to 8x cubed. Okay, just subtract 5 minus 2, that is equal to 3. Okay, for the second term, negative 70x squared divided by 10x squared, that is equal to negative 7. Take note that x squared divided by x squared, that is equal to 1. So, negative 7 times 1, that is negative 7. Then, negative 60x raised to the 7th power divided by 10x squared, that is negative 6x raised to the 5th power. Look at this one, 7 minus 2, that is 5. Negative 60 divided by 10, that is negative 6. Then for the variable, just copy the variable and then subtract the exponents. So we have this one. So the factors of 80x to the 5th power minus 70x squared minus 60x raised to the 7th power are 10x squared and the quantity of 8x cubed minus 7x minus 6x to the 5th power. Okay. Another, we have factoring the difference of two squares. We call this difference of two squares because the first and the last terms are both perfect squares and a negative sign in between them or a minus sign. Okay, so we're just going to follow this pattern in finding the factors of the difference of two squares. So just get the factors of the first term. One factor must be written here and the other factor is here. So there are two binomial factors of the difference of two squares. Two binomial factors. The first one are all positive. The second one has a negative sign in between. Okay? So, how did this second term or second terms in the binomial factors found. So just factor the second term or the last term in the difference of two squares polynomial. So the factors of negative b squared are positive b and negative b. So following the pattern, for example, we have 9a squared minus 49. 9a squared is a perfect square and 49 is also a perfect square. So just factor the first term. 9a squared factors are 3a and 3a. And the factors of negative 49 are 7 and negative 7. So take note, the first and the second terms in the two binomial factors are just the same. The only difference is that the first binomial factor are all positive. The second binomial factor has negative sign in between. Okay? Another example. 4b squared minus 144. The factors of 4b squared are 2b and 2b. While the factors of negative 144 are positive 12 and negative 12. Okay? So just follow this pattern. Another one. Factoring the sum and difference of two cubes. So this time, we have two cubes. We have the sum of two cubes, perfect cubes, and the difference of two cubes. So another two perfect cubes. So just follow this pattern. For the sum of two cubes, we have two factors, one binomial factor and one trinomial factor. To find the binomial factor, just get the cube roots of the first and the last term. So the cube root of a cube is a, cube root of b cube is b. And to find the other factor, just square this first term. So a times a is a squared. Then for the middle term, just multiply a and b, then get the opposite sign. So a times b is ab, opposite sign is negative, so you have negative ab. Then for the last term, just square the second term in the binomial factor. So b times b, that is b squared. Okay, for the difference of two cubes, we also have one binomial factor and one trinomial factor. So to find the binomial factor, just get the cube roots of the first and the last term. So cube root of a cube, that is a. Cube root of negative b cube, that is negative b. Remember in finding the cube root, it is the number or the variable that when you are going to multiply it by itself 3 times, you can obtain the number of variable that you have extracted the cube root. Okay. For example, the cube root of a cube is a because a times a times a is a cube. The cube root of negative b cube is negative b because if you are going to multiply negative b times negative b, that is positive b squared, times negative b, because there are 3 negative b's that we're going to multiply. So the positive b squared times negative b, that is negative b cube. Okay, so one binomial factor is a minus b, and then the other factor, the trinomial factor, can be obtained by first square this first factor. So a times first term in the binomial factor. So a times a is a squared. A times negative b, that is negative ab, but get the opposite sign. So positive ab. Then for the last term, we have negative b times negative b, that is positive b squared. Just follow these two patterns in factoring the sum and difference of two cubes. So example, we have the sum of two cubes. 8z cubed plus 27. 8z cubed is a perfect cube. The cube root is 2z. And the cube root of 27 is 3. You are going to multiply 3 by itself 3 times, you'll get 27. If you are going to multiply 2z by itself 3 times, you'll get 8z cubed. And then to find the other factor, okay, we're going to follow this one. Square 2z, so meaning 2z times 2z. So that is 4z squared. Then for the middle term, just multiply 2z times 3, that is 6z. And then use the opposite sign. So we have negative 6z. Then for the last term, we have 3 times 3. We have positive 9. Okay? Now for the difference of 2 cubes, we have 8x cubed minus 1. The cube root of 8x cubed is 2x. The cube root of negative 1 is negative 1. And then for the other factor, okay, 2x times 2x, that is 4x squared. Then 2x times negative 1, that is negative 2x. But then again, we're going to use the opposite sign. So we have positive 2x. Then for the last term in the trinomial factor, we're going to multiply negative 1 by negative 1. So you get positive 1. Alright? Now let's have perfect square trinomials. You can identify perfect square trinomials by just looking at the first and the last terms. So the first and the last terms must be perfect squares. Okay, just like this one, x squared plus 24x plus 144. This one is a perfect square. This one is also a perfect square. So to get the factors, we have two binomial factors. Okay, so just factor the first term. So x squared, the factors are x and x. Then 144, the factors are 12 and 12. So just factor the first and the last terms. Okay, you will notice that the two binomial factors are just the same. So we have x plus 12 and x plus 12. So we can rewrite it as the square of a binomial. So we have the square of the quantity of x plus 12. Another example, x squared minus 4x plus 4. X squared factors are x and x. Positive 4. The factors are negative 2 and negative 2. Why I use negative 2 and negative 2? Because I must consider the middle term. Since the middle term is negative, I am going to use negative for the factors of the last term. Since negative 2 times negative 2 is 4, but when I'm going to add negative 2 and negative 2, I can obtain a sum of negative 4. Okay, so this must be considered. So you have noticed that these two binomials are the same. So we can rewrite it this way, the square of x minus 2. So always remember that the perfect square trinomials the perfect square trinomial has two binomial factors that are the same. Okay? And then, look at the pattern. If all the terms in the trinomial are positive, all the factors are positive. But when the middle term is negative, the factors of the last term must be all negative. Okay, remember that. Another one. We have factoring general trinomials ax squared plus bx plus c when a is equal to 1. So meaning the coefficient of x squared is just equal to 1. For example, x squared plus 7x minus 30. So to get the factors of the trinomial, we always obtain two binomial factors. So in this case, in the general trinomial, we're going to make trial and error. So we're going to factor the first term and factor the last term. Okay, for example, x squared. The factors are x and x. And then the last term, the negative 30, take note that negative 30 has so many factors aside from 10 and negative 3. But then, why did I use positive 10 and negative 3? Because I need to consider the middle term. So, I must use factors of negative 30 in such a way that the sum must be the coefficient of the middle term. So that is why I'm using positive 10 and negative 3, because positive 10 times negative 3 is negative 30. But when I'm going to add 10 and negative 3, the sum is 7. Okay? So that's it. Then number 2, x squared plus 9x plus 18. The factors of x squared are x and x. The factors of 18, there are many factors of 18, but the only factors of 18 that will sum up to 9 is or are 6 and 3. Okay, 6 times 3 is equal to 18, but when I'm going to add 6 and 3, I can have positive 9. So all the terms in the trinomial must be satisfied by our two binomial factors. Again, we're going to check x times x, x squared. 6 times 3 is 18. Adding 3 and 6 will get 9. So, we're going to do that when the trinomial is in this form, when a is equal to 1. But when a is not equal to 1, for example, this one, 2m squared plus 3m minus 9. Again, we're going to use trial and error technique. So we're going to factor the first term and the last term. But we are going to consider the middle term. So 2m squared, the factors are 2m and m. Factors of negative 9 are negative 3 and positive 3. Why did I use this one? Why not 9 and negative 1? Because when I am going to multiply negative 3 times m, that is negative 3m. Take note of that. Negative 3m. And the outer, 2m times 3, that is 6m. 6m. So, negative 3m plus 6m, that is equal to 3m. So, let's check again. 2m times m, that is 2m squared. Negative 3 times positive 3 is negative 9. To get the middle term, we have negative 3 times m, that is negative 3m. For this one, the outer terms, 2m times 3, that is 6m. So, negative 3m and 6m, we have positive 3m. So, since all the terms are satisfied, meaning these two binomial factors are correct. Another example, 5x squared plus 32x plus 12. The factors of 5x squared are 5x and x. The factors of 12 are 2 and 6. Oh, why did I use 2 and 6? Because, okay, let us check. For the first term, 5x times x, we have 5x squared. For the last term, 2 times 6, 2 times 6 is equal to 12. And then for the middle term, we have 2 times x, that is 2x. 5x times 6, that is 30x. So 30x and 2x, we have 32x. So the three terms are satisfied, meaning the two binomial factors are correct. Now let us have an application problem. We have Number 1, if the sum of the square, take note, if the sum of the square of the number and 4 times the number is 21, what is the number? So, square of the number and 4 times the number is 21. So, to solve the problem, we're going to make a representation. So, let x be the number, and then we're going to make an equation based on the problem. So, according to the problem, the square of the number. So, if our number is x, so the square of a number is x squared. Then, 4 times the number. So, we have 4 times x. Then, why did I use plus? Because it says sum. So, the sum of square of a number and 4 times the number is 21. Look at this one. Okay, so this is our equation. Now, subtract both sides of the equation by 21. So, we have this one. X squared plus 4x minus 21 is equal to 0. So, you may notice that this one is trinomial of the form, and this is general trinomial when a is equal to 1. So, we're going to factor the trinomial. We have this one factor of x squared, or factors of x squared are x and x. Then factors of negative 21 are 7 and negative 3. Because 7 plus negative 3 is 4. And 7 times negative 3 is negative 21. Okay? Equate each factor to 0. We have x plus 7 is equal to 0. Then x minus 3 is equal to 0. Then solve for x. Okay? So x plus 7 is equal to 0. Subtracting 7 from both sides. So we have x is equal to negative 7. And then for this one, x minus 3 is equal to 0. Adding both sides by 3, we have x is equal to 3. Now to check whether which value of x is acceptable, let's have the checking. So we have this one. When x is equal to 7, substituting to the equation, x squared plus 4x is equal to 21, we have this one. Negative 7 squared, we substitute negative 7 to x, and then plus 4 times negative 7, substituted to x, and then copy equals 21. Then negative 7 times negative 7, that is 49. Then 4 times negative 7, that is negative 28. Copy equals 21. Then 49 minus 28, that is equal to 21. Copy equals 21. So the equation is being balanced. 21 is equal to 21. Let's check. Meaning, the x or the number could be negative 7. Now let's check whether the number could be 3. We have this one. Let us substitute 3 to x. In the equation, x squared plus 4x is equal to 21. So we have 3 squared plus 4 times 3 equals 21. 3 squared meaning 3 times 3, that is 9. 4 times 3, that is positive 12. Then copy equals 21. 9 plus 12, that is equal to 21. Copy is equal to 21. So we have 21 is equal to 21. So that is balanced or checked. Meaning, the x or the number could also be equal to 3. So the numbers could be negative 7 or 3. Another one. So the length of a rectangle is 3 less than twice the width. If the area is 9 square feet, then find the length and width of the rectangle. So we are going to find the dimensions of the rectangle. So again, we're going to start with a representation. So let L be the length, W be the width. Then we're going to make an equation. A, for the area of a rectangle, that is equal to length times width, or L times W. According to the problem, our L, or the length of a rectangle, is twice the width minus 3. So 2W minus 3. Then, we could rewrite this one, we could rewrite as this one. L times W, that is equal to A. Then substituting 2W minus 3 to L, since 2W minus 3 is the value of, or initial value of L, we can substitute that to obtain one variable. So we can substitute that to L. So we have 2W minus 3 times W. So instead of LW, we have 2W minus 3 for L times W. That is equal to 9 for our A. Okay, for the area of a rectangle. Then multiplying 2W minus 3 by W, so we have, if we're going to multiply, the product would be 2W squared minus 3W. And W times 2W, that is 2W squared. Negative 3 times W, that is negative 3W. Then, subtracting both sides by 9, so we have minus 9. Then that's equal to 0. Then factoring the trinomial at the left side, we have 2W plus 3 times W minus 3. Okay, the factors of 2W are 2W and W. Okay, so equating each factor to 0, we have 2W plus 3 is equal to 0 and W minus 3 is equal to 0. To solve for W, we have 2W plus 3 is equal to 0 for the first factor. So subtracting 3 from both sides, so we have 2W is equal to negative 3. Then divide by 2, so we have W is equal to negative 3 over 2. And then for the other factor, we have W minus 3, adding both sides by 3, so we have W is equal to 3. But then, since we're talking about dimensions of a rectangle, the sides can never be negative. So we're going to neglect W is equal to negative 3 over 2. We are not going to accept this answer. So meaning, we're just going to accept W is equal to 3. So to solve for the length using that value of W, so we have L is equal to 2W minus 3. We have 2 times 3, substituting 3 to W. Then copy negative 3. So 2 times 3 is 6. Copy minus 3. So 6 minus 3 is equal to 3. So meaning the length is equal to 3. So the length of a rectangle is equal to 3 feet. And the width is also equal to 3 feet. But let us going to check. LW is equal to A, or length times width is equal to the area of a rectangle. When L is 3 and W is 3, that is equal to 9 according to the given. That is equal to 9 feet. So 3 times 3, that is equal to 9. Copy equals 9. So since this is balanced, meaning the length of a rectangle is 3 feet and its width is also 3 feet. Okay, that's all.